So till now we saw how to print digits by using recursion, and we saw two methods, that was tail recursion and head recursion. Now let us get some more practice with recursion, and this time instead of just printing the digits, let us add all of the digits together. So for example, let us create a function called as up to, and if you pass the argument of 3, at that time we want to get the sum of all of the digits. So this function should return 3 plus 2, that is 5, 5 plus 1 is 6. So this function should return us 6. So let us go ahead and let us create the file for this one. So inside the directory of recursion, let me create a new file and let me call it as sum of digits.ex. The first thing, we want to define a module, and as per the community convention, let us write the application name first. So the application name is tutorials, and then the folder is recursion, and then the file name is sum of our digits. Let me collapse my sidebar. Now here let me first write a very simple recursive function, and then we will try and trace that function. So let us call a function by the name of up2, and let us pass the argument for the numbers, and let's see what we can do this time. So this time we can use a very simple recursive function. We can say that for each iteration I simply want to add the number, and the next time I want to call the same function of up2, but every time my argument should be number minus of 1. But this function will never end because we don't have a base condition. The number will keep on going into negative values. So we also need to define a base condition. So on the top, let us create the base condition. So let me create a new function by the name of up2, and this time let us pattern match on 0. Suppose the number is 0, then at that time I simply want to return back 0. Now remember, if we have a single line of return, then we can write it on the same line, and in case if we have a regular function, then the last line is automatically returned. We don't have to use the keyword of return. So let me save the file. First let me run the file, and then we will try and trace the recursive function. So let me open up my terminal and let us enter inside IEX. So I can say IEX.s, that stands for start. I want IEX to start my mix, and let me clear all of these things. Let us create an alias. So you can say I want to create an alias for tutorials.recursion.someDigits. Let me clear up the screen, and now we can say from the module of someDigits, I want to use the function of up2, and let me pass the argument of 3. So as expected, we get the answer as 6. So what happened? 3 plus 2 plus 1 is equal to 6. Now let us see how we can trace this recursive function. So this is our program for someDigits, and this is the functions that we wrote. On line number 1 we have the base case, and on line number 3 we have the recursive case. Now let us see what's going to happen. Let's take the same example and let us pass 3 to this function. Now is 3 equal to 0? No, 3 is not equal to 0. So Elixir will go to the next function, and here what's going to happen? Here we are saying that we want to add the number, and after adding the number we simply want to call the function recursively. So what's going to happen is we get 3 plus, and again we call back the same function, but this time the argument is number minus 1. That's why the next time we are calling the same function up to with an argument of 2. Now what's going to happen? Is 2 equal to 0? No. So Elixir will go to the next function. Now what happens? Again the same thing, number plus the recursive call. So what's going to happen is, so this will evaluate 2, we get the number, so the number in this case is 2, so 2 and plus, and then we again get back the recursive function, but this time the argument is 2 minus of 1, that's why the argument becomes 1. Now again let us go back to the same function. Is 1 equal to 0? No. Then we will go to the next function. Now here again the same thing repeats. So this time again the number plus, that means 1 plus, and let us call the same function again, but this time the argument becomes 0. So what's going to happen this time? This time we have a base condition in place, which is right over here. We are saying that whenever the argument is 0 At that time, we simply want to return back 0. So this function right over here, this will simply return back a 0. So now what has happened? We have exhausted this call, and now the control has to return back to the earlier functions. So what's going to happen? So this entire expression 1 plus of this function, this will be evaluated to 1 plus 0 is equal to 1. So this entire expression evaluated to a 1. Now the control will go back to this function right over here. But this time what's happening? So this entire function call evaluated to a 1. So what's going to happen right over here? This entire expression would be evaluated to 2 plus 1 is equal to 3. Now again the control will go back to the earlier function call. So this time what's happening? The function call of up to and 2 has evaluated into a 3. So this entire expression gets evaluated to 3 plus of 3. That means we get back a 6. And this is what is returned from our function, which you can see right over here. Now if you have a look at this function is neither head recursive, neither it is tail recursive. It is just a recursive function. But can we convert this function into a tail recursive function? Yes, we can. So let me show you how we can convert this function from a regular function to a tail recursive function. So let us create a new function right over here, and we can say that this time the up to function would be tail recursive. Now first let me write the function definition, and then I will explain what's happening. So this function is going to accept two different parameters. The first parameter is the number as it is, and I also want to accept one more parameter which I am going to call as accumulator, so which stands for ACC for short. Next, let us think of our base condition. So as we just saw over here, we have a base condition where the number is 0. So let's try and replicate that same logic right over here. So in case if I say that my number itself is 0, then at that time I simply want to return back my accumulator. So I can say do ACC. So this is our base condition. Now let us see how we can define our recursive condition. So let me copy and paste right over here, and this time we want to get a number, and let us take the return statement in a different line. So let me take it out. Now let's see what we can use as our recursive call. Now again, please let me repeat. First let me write the code, and then when we see how to trace the recursive algorithm, at that time the logic will get clear. But right now what I want to do is I simply want to call the same function again, but for each iteration I want to say that my number has to decrease by 1, and for each iteration I simply want to add my accumulator with the number, and that's it, we are done. So let me save the file and let me open up the terminal, and now I can recompile the module of some digits. Now let me clear up the screen, and we can say that we want to use the tail recursive version, and let me pass 3 to this one. Oh, we have an error. That's because we also need to pass the accumulator. So this function, the tail recursive, requires 2 arguments, and I pass only a single argument. That's why we get an error. So let me clear this up, and we can say that the accumulator has to be 0, and this time we get the answer back as 6. Now we can slightly improve our program. Each time, instead of passing an accumulator, what I can do is I can simply set the default values. So let us go back to the code editor, and let me copy and paste this line. So what we are going to do is we are going to create a function definition, and since we are just creating the function definition, or you can say just the function header, we don't need to specify the return statement, so this has to go. And here we can say that the default value of the accumulator is 0. So in case the accumulator is not specified, at that time the accumulator would be set to 0, and here instead of 0 we can say that the first argument can be any number. So what we have done right over here is we have simply created a public function. So as our code editor is helping us, it's just a public function with a given name and body. So normally these things, they help you with the documentation of your code. The first thing, we again need to recompile our module of some digits. Let me clear up the screen and let us try to invoke the same function. But this time, since we have a default argument for the accumulator, I can simply leave it out. And again we get the same answer back as 6. Before we go ahead and trace this recursive function, we can do one small thing. Now what happens, this function is slightly expensive because it takes slightly more memory. So what we can do over here is we can simply call the tail recursive function and pass the argument of number, and that's it. So now let us open up our terminal and let us again recompile. Let me clear up everything, and this time if I do sum digits dot up to and if I pass the argument of 3, so what's happening? Behind the scenes we are still invoking the tail recursive function and we are getting the same answer back as 6. So now let us go ahead and let us see how we can trace the tail recursive function. So this was the last function. Now we want to trace the tail recursive function. On line number 2 we just have the function definition. So this function accepts a number, and for accumulator we have set the default value as 0. On line number 3 we have the base condition, and we are saying that whenever we get the number as 0, at that time we simply want to return back the accumulator. The next is our recursive call. Now let us pass the argument of 3 to this function and let us try to trace this recursive function. So we have an initial call like this. The value of number is 3 and by default the accumulator is set to 0. Now let's see what's happening. Now is 3 equal to 0? No, it's not equal to 0. So Elixir will go to this function right over here. Now what's happening? Now we are calling the same function back. Okay, so what we need to do? We need to call the same function back. But what happens to the argument? So the first argument is we simply want to decrement the number by 1. So in this condition, what's happening? The number is 3. Okay, so we get 3 over here. And for each call, we simply want to subtract 1 from it. So the answer here is 2. And the next parameter is right over here. So we simply want to add the accumulator with the number. So let's go right over here. So what's the accumulator? So as you can see, initially the accumulator is 0. So we get a 0 right over here. What's the number? The number is 3. So 0 plus 3, we get a 3 right over here. So this entire function would look something like this. The new number is 2 and the new accumulator is a 3. Now let's see what's going to happen. Is 2 equal to 0? No, it's not. So we will go inside this function. Again, we have to recursively call the same function. So let us see what's going to happen. So again, we call the same function. But this time what happens? The number is -1. So this 2 comes over here, minus of 1. So what's the remainder? It's 1. The next is accumulator plus the number. So in this case, what is the accumulator? The accumulator is 3, which comes right over here. What is the number? Number is 2. So 2 comes over here. So 3 plus 2, we have a 5. So this function gets evaluated to right over here up to the number becomes 1 and the accumulator becomes 5. Now again the same thing, we have to call ourselves back again. Now is 1 equal to 0? No. So we go to the next condition and again we call ourselves back. So what's going to happen this time? So this time number is 1, 1 minus of 1. So that's why we get a 0 right over here. The next is again the same thing. Accumulator plus the number. So what's the accumulator? The accumulator is 5. That's why we get a 5 over here. What's the number? The number is 1. So we get a 1 over here. So 5 plus 1, we get a 6. That means we can say that this expression is evaluated something like this up to 0 and 6. Oh, so this time the number becomes 0. So what's going to happen? So it's going to go right over here. So is the number 0? Yes, the number is 0. So what do? We simply return back the accumulator. So that's what is going to happen right over here. We simply have to return back the accumulator. So what's the accumulator? The accumulator is 6 and that is what we have to return. So now is there anything left? Nothing is left, and that's it. We get the answer back as 6. So as you can see, these tail recursive functions are very special. The first reason is they require less memory. And why do they require less memory? It's because they are recursively calling themselves back again. Now if you come from some other compiled language like Java or maybe like Python, you must be thinking that for each of these calls we must be allocating different stack memory. But no, that does not happen in Elixir. Since Elixir is a functional programming language, This function calls are highly optimized. So what's happening? We are simply reusing the same stack and hence there is no extra memory allocation. So always whenever possible try and use tail recursive functions because they are more memory efficient. In terms of speed it could be more, it could be less, you don't know. But in terms of memory for sure they require much less memory. Well, that's it for this video and I will catch you in the next one.